Hey everybody, welcome back to chemistry. And so what we're going to talk about this time is I want to explain what state symbols are and how they are added into chemical equations. Okay, so a lot of times you will have chemical equations and then you'll have to include something called state symbols. What I'm going to do is try to explain this to you sort of in the context of actual chemical equations. And so what's going to be a little bit different this time is before what we did is we took a look at equations that have formulas and we just kind of balanced such that the atoms for each element were balanced on either side of the equation. But now what I want to do is I want to start out with a word equation and then convert that into a chemical equation and then balance that and then include state symbols. So let's go ahead and try the first one. So the first one is aluminum metal is added to an aqueous solution of hydrochloric acid, producing the products aluminum chloride and hydrogen gas. So before we launch into that, let me sort of mention what the four state symbols we usually use in chemistry are. So one of them is parentheses S, and so if that's beside a compound, as you'll see in a few minutes, that indicates that the compound is in the solid state. And then if you have an L here, then the compound or element is in the liquid state. And if you have a G here, it's in the gaseous state. And then there's one you may heard of, or maybe not, but it's AQ. So AQ stands for aqua, which means water. And so this refers to an aqueous state. So let me talk a little bit about what that is. Okay, aqueous state usually refers to a situation where you have compounds, oftentimes ionic compounds, dissolved in water. So if you have a case where you have an ionic compound, you kind of can tell from the explanation of the problem that the ionic compound is dissolved in water. What you would do is, if the ions are dissolved in the water, we'll talk more how you figure about that later, but if the ions are truly dissolved in the water, you indicate that by using the symbol AQ after you write the formula for the ions. So I think the best thing for me to do is just sort of explain that with a few problems. So let's do the first one. So again, we have that word equation there, and so I'm just going to take that and write a chemical equation. So when I write it, it will not be balanced. And also I want to include state symbols. So we have aluminum metal. So we have Al. And so if it's a metal, you can probably guess it's in the solid state. So we would indicate that by putting a little parentheses S there. And it says it's added to aqueous hydrochloric acid. And so eventually you'll learn the formulas for acids. And so you will learn that hydrochloric acid is HCl. And we have some information about it. It said it's an aqueous solution. So what that indicates is that there's probably some hydrogen chloride dissolved in water. If so, these are ions dissolved in water. And so you would indicate that this compound is dissolved in water by putting an AQ here. And then, so we have these two materials. One is an element, aluminum, one is a compound. And apparently, they're going to form products. And so let's see what those are. So we have one product is aluminum chloride. Now, it may be difficult to understand from the question itself what state this is, and so you have to use maybe sometimes a little bit of imagination. And so what you might expect is as this reaction goes, the reactants go away and products form. So what is going on is products form in this aqueous solution. So you might imagine that this ionic compound will form an aqueous solution, so you might make a good guess that this is AQ. But also another product is hydrogen gas. And so hydrogen gas is H2, and then this is G. Okay, so now I gotta balance this guy. Well, we don't want to leave an equation unbalanced here, so I will try to do this kind of as quickly as I can. So what I'm going to do, just let me put a 2 here. And so we have 2 aluminums. I'll balance that aluminums last because that is an element on this side of the equation. Let's go for the chlorines first. So we have 2 times 3 chlorines is 6 chlorines. So to have 6 chlorines here, I put a 6 in front of here. 6 hydrogens here. on the reactant side, 2 hydrogens on the product side, so I'll put a 3 here, so the hydrogens are balanced, and so the last element I'll balance is aluminum, 2 aluminums on the product side, 1 on the reactant side, so that should be a balanced equation. So this is a balanced chemical equation for the information that we have, including state symbols. Okay, so let's move on to the next one. Okay, so in this problem we have sodium hypochlorite salt is added to liquid hydrogen peroxide, which breaks down to produce water, aqueous sodium chloride, and oxygen gas. Okay, so we have sodium hypochlorite salt. So you're going to have to figure out a formula for that. And so it is NaClO. And it looks like it is a salt, so it's indicated immediately that it's in the solid state. So you can write that there if you want. Is added to liquid hydrogen peroxide. I don't think you'd be expecting to know the formula for that. I just happen to know that it's H2O2. It's indicated in the problem that it's a liquid state, so I'll put an L here. And then what we're going to do is we're going to get some products. So let me write this down here. We're going to get water as a product. And we're going to get aqueous sodium chloride, so we have NaCl here, and then we have oxygen gas. So let's talk about what states these are in. So water as a product, it looks like we're having other stuff form in the water, so it's not really pure water. There's ions from sodium chloride forming in the water, so water really is aqueous. So we could probably write AQ here. Sodium chloride will be dissolved in the water. So is in an aqueous state, and then oxygen is a gas. So that should be fine. Now, one question you might ask is so if we have sodium chloride dissolving in water and it's in the aqueous state, how about sodium hypochlorite? Why isn't this an aqueous state? And the reason why it's not in an aqueous state is because it's not dissolving in water. Instead, it's dissolving in hydrogen peroxide. And so we cannot really indicate that this is in an aqueous state. So that's the reason. Now, you can balance the equation, but as I recall, things are almost balanced, or it could be completely balanced. So let me check a few things. Sodiums are balanced, chlorines are balanced, hydrogens are balanced. How about oxygens? 3 oxygens in the reactants, 3 oxygens in the product, so it looks like a balanced equation, so that is complete. So that's good. So we will move on.